The Pythagorean theorem is a theorem about right triangles. So let's talk about the right triangle. So it's a right triangle. We use a symbol like this. It's called the square to show that that is a 90-degree angle or a right angle. And we need some vocabulary. The two sides of the triangle that make up the right angle are referred to as the legs. The side opposite the right angle is called the hypotenuse. And the Pythagorean theorem states that the square of the legs of a right triangle are equal to the square of the hypotenuse. Now, before we even get to that, which I'm going to try to show you that, we usually refer to the short leg as side A, the long leg as side B, and the hypotenuse as C. And so the Pythagorean theorem is A squared plus B squared equals C squared. It's nice that way because it's alphabetical, but I'm going to encourage you to use it as C squared, the square of the hypotenuse, is equal to the sum of the square of the legs. And you'll see in a later lesson why I prefer to put the C squared in front. All right, now for the demonstration. So when we say the square of the legs, we mean make a square with the legs. So you can see I've drawn a square on each one of those sides, and you can see that the one on the left is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So this square has 25 little squares in it. And then the long one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 across, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 down, which makes this is 144. So if the Pythagorean theorem is true, the hypotenuse squared equals 5 squared plus 12 squared, which is 25 plus 144. Well, that means that the hypotenuse squared is 169. And if we square root each side, C equals 13 units. Now remember, when we square root C squared, we get C. And when we square root 169, we should get plus or minus 13, except for when we're talking about an actual length. And then, of course, there's no negative length. So let's show that this is true. Let's take the green side, which is the hypotenuse, and stand it up. And now make a square with it. And let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 long. And by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 wide. And of course, that gives us 169. And so it is 13 units long. That hypotenuse is 13 units long. So this illustrates that the Pythagorean theorem works. Move that back down there so we can see our right triangle. So let's get a little experience now using the Pythagorean theorem. So let's try this one. If you'd like to, you can pause the video and try it on your own. But of course, what we're looking for is the missing side. A lot of times we'll call it X. We can call X or C if we want to use the letter that's more commonly used for the hypotenuse. But X squared must equal 4 squared plus 7 squared. So X squared must equal 16 plus 49. So X squared must equal 65. So then we square root each side. And we would be looking for X equals plus or minus, but again, can you have a negative length? And the answer is no, you cannot. So it's not plus or minus, it's just a positive. And if we want to estimate it, we know it's between 8, because that's the square root of 64, and 9. And we know it's really, really close to 8. So my guess is 8.1. And now we're going to do it on a calculator and check that. So 8.06 would round to 8.1, and we always put units on there to remind ourselves that it's not a negative. You should always be putting, anytime you square root x squared, that number should be plus or minus, or it should be an actual length. So putting units on it reminds us I don't need to put plus or minus on it. Let's try another one, this time not looking for the hypotenuse. So let's look at this one, this triangle. First of all, could this triangle even exist? Do you notice something about this triangle in yellow? I did this just to see if you're paying attention. 11 has to be a shorter length than the hypotenuse. The hypotenuse is across from the greatest angle, so it has to be the longest side. So it could not be 9. So let's go with, instead of 9, let's go with 14. Well, now what we have, oh yeah, and let's call the short side x. What we have now is 14 squared equals x squared plus 11 squared. So 196 equals x squared plus 121. So then we subtract 121 from each side. So 75 equals x squared. And of course, we have to square root each side. And I know that 75, again, is between 8 and 9. 64 is 11 below it. And 81 is only, 6 above it. So I know it's closer to 9. Let's see, I'm going to guess 8.7 this time. And let's see if that's close to x. Can you guess? I've had a little experience with this. 8.66, and it goes on from there. So if I round it, 8.7 units. Well, let's go for one where we are missing the long leg. So the short leg is 3, hypotenuse is 12. We're looking for the long leg. So 12 squared will equal 3 squared plus x squared. And by the way, does it matter what order we put these in on the right side, the legs? Do I have to put x squared and then plus 11 squared? Do I have to have 4 squared before 7 squared? Hopefully you understand that the answer is no. Since we're adding, it doesn't matter which one comes first. But I like to keep them in order. So 144 equals 9 plus x squared. So I'm going to subtract 9 from both sides. And 135 equals x squared. Square root each side. And 135 is in between 121 and 144, so I know it's between 11 and 12. And that equals 11.61895. It goes on, so approximately 11.6 units equals x.